Welcome to a session about A-star search algorithm. A-star search algorithm is one type of informed search. In the artificial intelligence, searching techniques takes very important role. So, two main categories of searching techniques. One is uninformed search, another name is blind search. Another type is informed search. Another name of informed search is heuristic search. In the uninformed search, in the name itself, we have that blind search. It does not use any domain knowledge. So in the systematic way, it can follow some procedure and find the goal node. And while considering the informed search, it should use the domain knowledge, that is, it is having some additional information to reach the goal node from start node in the optimal way. Best path we can easily find with the help of additional information that is named as heuristic function h of n. That additional information will be helpful to reach the goal node from the start node in the optimal way. So that is the main difference between informed search and uninformed search. So while taking the informed search, we have two important types are available. One is the best first search algorithm and another one is the A-star search algorithm. In the A-star search algorithm, we have to calculate the function value that is denoted as f of n. So f of n formula is g of n plus h of n. So g of n is cost so far to reach n and h of n is the estimated cost from n to the goal state. Okay, these f of n will be helpful to reach the goal node from the start node in a optimal way. And f of n is the total cost, and using this formula for each and every path, and we are finding the value, and based upon the lowest f of n value, that path will be expanded. So this is the procedure or algorithm we can use for A-star search algorithm. So until we reach the goal node, all the leaf node, okay, so whatever the value, so we cannot left over the remaining part, all the nodes, hold condition, we are keeping some path, that path also we are taken into account, and then up to the final stage until we reach the goal node, so all the hold nodes will be taken into consideration. Okay, so this is the easily we can find the optimal path with the help of A-star search algorithm. So let us take some example problem to understand A-star search algorithm. So consider this problem. Okay, A-star search algorithm. Okay, so we need to find out the path from the root node or initial node or start node to the goal node. Okay, that is the problem. So from the S to G, what is the optimal path? We need to find out. So now this S is the starting node and successor of S is A and G. And we have that A and A connected with B and C. And C connected with D and G. So like that we are exploring this tree structure. So in this tree structure, all the nodes available here, and then these values. Okay, so what is the use of these values? These values are called as path cost. S to A, what is the path cost value? Mentioned in this diagram, 1. A to B, the path cost is 2. A to C, the path cost is 1. C to D, the path cost is 3. So now these values are helpful to find the G of n value. We know the formula to find out the f of n value. F of n is equal to G of n plus h of n. We need two values. One is the g of n value and another one is the h of n value. So g of n value we can calculate from this diagram. All the values are available here. Each path contains the values and we need another value. So another value is heuristic value. So heuristic value denoted as h of n. For S, the h of n value is 5, A, h of n value is 3, B, h of n value is 4, C, h of n value is 2, D, h of n value is 6, G, h of n value is 0. So from this our aim is we have to get the optimal path from S to G. So what are all the steps following for finding this path, optimal path with the help of A star search algorithm? From these steps we can understand. So start from the initial node. Okay, here which one is the initial node? S is the initial node and successor of S reachable nodes are A and G. Okay, two reachable nodes are available from S, A and G. So now we consider S to A. So S to A, what is the f of n value? F of n is equal to g of n plus h of n. So g of n value from S to A we can see from the diagram. S to A, g of n value is 1 and A. Okay, so this A. Okay, this particular node. Okay, so that last point we can calculate the h of n value. We can take the h of n value from this tabulation. Okay, A corresponding h of n value is 3. So 1 plus 3 equal to 4. Then another reachable node from S is G, S to G. So S to G, what is the f of n value? F of n is equal to again the same formula and applying this formula. Here g of n value is 10 and h of n value is 0. Okay, always the goal node, another important thing we should remember, goal node always the heuristic value will be 0. So 10 plus 0 equal to 10. So now we have these two values. These two values of f of n. From these two values, which one is the lowest f of n value? So here 4 and 10. 4 is the lowest f of n value when compared to 10. So now we can consider this path first and then we can keep this path as hold. Okay, we are not removing this path, just keep it in hold condition. Now we are expanding this path S to A. Okay, so after reaching S to A, successor of A, B and C. Okay, two nodes are available, B and C. So now we can consider the two cases S to A to B, S to A to C. S to A to B, S to A to C. So f of n is equal to 1 plus 2 plus 4. Okay, here very important thing you can consider. So how we are calculating the g of n value? The total path cost. Okay, S to A, what is the path cost value? 1. And A to B, what is the path cost value? 2. So 1 plus 2, that is the total g of n value, plus B. What is the h of n value for B? 4. So 1 plus 2 plus 4 equal to 7. Similarly, S to A to C, f of n value is equal to 1 plus 1. 2 is the g of n value and C, what is the h of n value? 2. So 2 plus 2, 4. So now what are all the values available in the hold condition? 10 available in the hold and this path also available in hold. This path now we are calculated 7 and another value is 4. So comparing these three values, which one is the lowest value? S to A to C. Now expanding this path. Okay. So this 7 will be keep it in the hold condition. So now we are expanding S2A to C. S2A to C. This C connected with D and C connected with G also. So now we can write two paths S2A to C to D, S2A to C to G. So now the f of n value is equal to 1 plus 1 plus 3 plus 6 equal to 11, and f of n for S2A to C to G, f of n is equal to 1 plus 1 plus 4 plus the G, the h of n value is 0. So then this is 6. Okay. So now we are considering what are all the values available in the hold. So 10 is available in the hold condition. Now in the previous step 7 also available in the hold condition, and then now 11 available, 6 available. Now we are seeing this already we reached the goal node with lowest f of n value. Okay. So now the optimal path we can select for this A star search algorithm problem S2 A2 C2 G. Okay. Here also we have that one S2G, one path is available, but S2G, the value f of n value is 10. So 10 and 6, which one is the lowest value? 6. Okay. So like this, all the leaf node, okay, what are all the hold condition path we can consider for the further process, then comparing all the f of n value, then select the lowest f of n value, then expand the particular path and to reach the goal node in a optimal way. So this is the procedure we are following to find the optimal as well as the best path from start node to goal node with the help of A star search algorithm. So now we can see the another problem, the same kind of problem. So easy understanding, then you can work out more problem, you can get the better idea. So now this is the tree structure. Okay, so what are all the nodes available? S, A, B, C, D. In the problem itself, they are mentioned that which one is the start node? S is the start node and D is the goal node. Okay. The values available in the problem is called as path cost value. From that only we are calculating what is the G of n value. So from this tabulation we can take the heuristic value, that is H of n value. So start from the start node or initial node S, successor of X, A and B. So now we have the two paths S to A and S to B. What is the f of n value? Formula G of n plus H of n. So 1 plus 6 equal to 7, and then S to B, f of n is equal to 4 plus 2. 4 plus B, what is the value in the heuristic function tabulation? 2. So 4 plus 2 equal to 6. Now comparing these two value, these two f of n value, which one is the lowest value? S to B. This path contains the lowest f of n value. Then expand this path S to B. Okay, so S to B. So S to B we have the another reachable node from B is C. So S to B to C, f of n value, G of n, here also very important note. The G of n is not only the particular path cost from the start node to the particular node, what is the total path cost we should consider. So 4 plus 2. 4 plus 2, and then what is the C heuristic value given in the tabulation? 1. So 4 plus 2 plus 1 equal to 7. Now, so this is one of the value, and here already we have this S to A 1 plus 6, this 7 one of the value. Okay. So these two values are similar value only. So any one value, any one path we can take it and expand first. So now I am considering this path. So S2, B2, C2, D. What is the f of n value? 9 plus 2 plus 3 plus 0. Okay. The D value is here. What is the value? S2B. So S2B, the value is 4. Okay. This is 4 plus 2 plus 3. Okay. So 6 plus 3 equal to 9. And then we are having that another another path also contains the same value. So next I am expanding this S2A. So S2A to B and S2A to D. So S2A to B and S2A to D. Okay, so these two possibilities are there. So then we can consider both the cases and calculate what is the f of n value. F of n is equal to 1 plus 2 plus this is the total g of n value plus 2 equal to 5, and S2A to D, f of n is equal to 1 plus 12 plus 0 equal to 13. So now we are taking this S2A to B and expanding, comparing all the values. Okay. So now this is one of the hold condition and 13 is also one of the hold condition and 5 also there. So from these three values, which one is the least value? Lowest f of n value we should consider, and this is the least value of f of n. So now I am going to expand this path. Okay. So S2A to B to C, S2A to B to C to D. So now S2A to B to C, what is the value? 1 plus 2 plus 2 plus 1 equal to 6. So now we are comparing all the hold condition. What are all the values available in the hold condition? Comparing all the values, 6 is the lowest value. So then this path can be expanded. Now S2A to B to C to D, the value is 1 plus 2 plus 2 plus 3 plus 0, the value equivalent to 8. Okay, so now we reaches the goal state D with minimum cost 8 when compared to, so we are seeing here also we are having that goal state S2, B2, C2, D, but here what is the f of n value? 9. Okay, so like this we are not removing the path once we are completing the expanding. We have to take all the leaf node and its f of n value, and which f of n value is lowest value, that path will be expanded for further process to find the optimal path from start node to goal node. So this is the way we can use the A star search algorithm. So another one more example, it is very interesting example. So here this is the structure, and from this our aim is from home to university. Okay, home is the starting point, starting location, and university is the goal state and ending location. From home to university, how to find out the optimal path. Here also the path cost given in the diagram itself, and the corresponding h of n value for home 120, bank 80, garden 100, school 70, railway station 20, post office 110, police station 26. These values are heuristic value. So this is also tabulated. So now our aim is we have to find the path from home to university. So first initial state or initial location is home. So from the home, what is the f of n value? F of n value is equal to 0. Always the starting point, the path cost value, that is g of n value is equal to 0. At the end node or goal node, always h of n value is equal to 0. So this point also you can remember. Whether they are not given the value in your exam question paper, you can take it as at the initial point g of n value is equal to 0. At the end point h of n value, that is the goal point h of n value is equal to 0. So for the home, the value is 0 plus 120, f of n value is equal to 120. And step 2. So from the home, this location can be expanded, and then it is connected with bank, home connected with garden, home connected with school. So home to bank, what is the f of n value? 125. Home to garden, what is the f of n value? 140. Home to school, f of n value is 120. And from this comparison, okay, we have to consider this is the leaf node now. So for these three nodes, which one has least f of n value? So 125, 140, 120. So we can consider school, okay, home to school. So home to school and expanding this path, school connected with home, school connected with railway station, school connected with post office. So school connected with home, what is the g of n value added with h of n value? So 100 plus 120 equal to 220. And railway station 125 plus 20, 145. And post office 109 plus 110 equal to 211, okay, 219. Now what are all the leaf nodes available? 125 bank, 140 garden, home 220, railway station 145, post office 219. Okay, we consider all the leaf nodes. Okay, consider all the leaf nodes. Once we reaches the school, don't think that we can expand only these path alone. It is not necessary. That is the another advantage of A star search algorithm. We can find the optimal path. We can consider all the leaf node, and which leaf node contains least value of f of n, that path can be further expanded. So now bank contains the f of n value, very lowest f of n value, that is the 125 when compared to remaining leaf nodes. So now bank, home to bank. The bank can be expanded, that path can be expanded. Bank connected with home, bank connected with police station. The home, what is the f of n value? 210. And police station, what is the f of n value? 131. Now we can see the diagram, what are all the leaf node available? 210, 131, 140, 220, 145, 219. Compared to all the f of n value, police station contains the lowest f of n value. So then we can further expand the police station path. So home to bank, bank to police station. So now the police station path can be expanded. Police station connected with bank, police station connected with university, and this during this bank location, what is the f of n value? 245. At the university, we already know h of n value is equal to 0. So 133 plus 0, 133. So now we are considering all the location. We reached the goal node also, as well as with least cost, we reached this goal node. Okay. So then the proper optimal path for this problem while using the A star search algorithm, home to bank, bank to police station, and police station to university. Okay. So path, optimal path is home to bank, bank to police station, and police station to university. So this is the way we can use the A star search algorithm to find optimal path with the information of g of n and h of n. The function value formula f of n is equal to g of n plus h of n. Thank you.